Okay, next video is on the vernier caliper measurement. So we have a vernier caliper right here, and you would think in this day and age with all this electronic stuff that we wouldn't have to ever read one of these, but truthfully it is the most cost-effective way of measuring when we start getting into large measurements. So much of the equipment is still verniers, and you'll have to know how to read these. So okay, so this was done by Dr. Zeiden at UW-Platteville here. And again, he's really good at doing these presentations. Okay, so a vernier caliper is really useful for measuring in a bunch of different ways. And so this picture that we're looking at here, you've got little nibs which are on the top of the area over here. So for some reason you can't see my mouse. You have the jaws, and then you have in the back you have a depth measuring device. Okay, and the way it works is kind of a trick of physics in that there's an interference pattern between two sets of lines, and that magnifies how you know where in particular you are. So I'm going to explain that. So here is the vernier caliper, and let me okay, so I'm going to tell you a little bit how this works. So here we have the nibs here, and what you'll see is as you open them up you can measure inside. So if I wanted to measure the inside diameter of something, I don't know, let's say this. It's a manhole cover. Got lots of students working for these guys. Okay, so what I would do is I would take and open these up until they got to the diameter of the inside of this. Now the thing is, it will always, if you mess up, it's always going to read smaller, because what will happen is, if you look at carefully here, if I'm not in the center, you see that? I'm off to one side. I think I got the diameter, but really it's a smaller than, so what I got to do, smaller than the actual measurement. So I have to kind of like wiggle this back and forth until I find the maximum dimension, and then I carefully pull it out so that I can read it, because if I don't carefully pull it out, it'll move a little bit. Okay, so now I have this measurement, and now I have to go and read it. Okay, if I want to do the outside diameter of something, I would just put it on the outside like this. So measure those and see what the tolerance is between the two of them. Okay, and if I want to measure the depth of something, how deep something is, I can use that again. Okay, so what I'm going to do is I'm going to come down, and it depends if I want to measure this depth or that depth. Okay, but I'm going to use the back of it, and I could probably measure both, but I'm going to go with a smaller one there. Okay, so now that distance right there is the depth of it, and I'm going to go back on this, and I would measure it again. I would just read the scale up here. So there's three different things you can do. So if you want to buy something for measuring, I don't know, you do some machining, or you do some car work and you want to measure diameters of stuff, not super accurately. This is probably plus or minus a couple thousandths of an inch accuracy. A dial caliper is the other thing you could use, and a dial caliper just has a little, and it goes around and around in a circle, and you can do all the same things. Dial caliper might be about, these are probably like $15 for cheap ones, maybe $100 for a good one. These ones are probably $20 for a cheap one, and maybe you can go up in the $200 range for like a 6 or an 8-inch one if you get a really good one. The other thing you could get is a digital one, which actually has a digital readout right here, and that's probably what I would recommend, just because it's faster to read. It's not any more accurate. The accuracy is like how well they machine the actual material here. So yeah, and Okay, so we're back to the caliper here. Here we are reading the caliper. And so you can see that, and this is the inch version of it, okay? So along the bottom there's 25 divisions. And if we, he did a great job at this, and we zoom in on that. Okay, so now we have 25 divisions along the bottom. Now, I don't know if you remember, if you already watched the micrometer video, but if you look carefully, we have, we have 100 thousandths places here. 100, this is 1 inch, 1.1. So 1 inch, 100 thousandths, 1 inch, 200 thousandths, and that's divided into 4 divisions. Now, each one of these divisions then would be 1/4 of 100 thousandths, which is 25 thousandths. Okay. So the weird thing about a vernier caliper is that you always measure. You're always doing these measurements based off the 0 here. Okay. You got to be careful because a dial caliper, it's based off of the front edge of this piece of metal right here. Okay, but always in a vernier, the 0 is where you're reading from. Okay, so this is the vernier scale, and over this distance, it's like 1 division more than the division over here. So somewhere along here, only one of these lines will line up. Now it's a little bit hard to see on the computer, and I don't know how he did this, but he did it very carefully to get this animation set up. But let's go through the whole process. But the thing I want you to know is the reason why there's 25 along here is that the 100 thousandths are broken into 4 divisions. Sometimes they're broken into 2 divisions, so this would have 50 of these along here, and only one of those would line up. It would be much longer, though. Okay, so let's see how. Okay, so how do we read this? So we're reading from the 0, remember, again, and so we got 800 thousandths, and then we're like 1 division past the 800. Now, if your eyes aren't very good, you can't hardly read these things. You have to have a magnifier. But so we got 800 thousandths. So it's not an inch. There's 1 inch. So it's 0 inches. So the first thing you do is you would write 0 inches down, and then you would write, okay, how many 100ths? So it's 800 thousandths, even though it says tenths there. They don't say tenths. So it's 800 thousandths. And then we have 1 division past the 800, so that's 25 thousandths. And then what's the deal here? And then we're slightly past that. Okay, so the next thing you would write is 25 thousandths because it's 1 division past it. Then you're going now the final dimension that you're going to do, this is in thousandths of an inch, and you're going to read along the bottom here. So what we're going to do, I think it actually zooms in a little bit. Yeah, okay. And it's looking like, oh, that's 15, 14, 13, like 12 would line up. Okay. So that's also 12 thousandths of an inch. Okay, so 0.012. Don't write 0.120 because that would be 120 thousandths of an inch. Not, so you got to really be careful with that decimal place. Okay, so you get it. Okay, so 0.837 when you add those up. Again, this is how you're going to show your work when you do the problem. The problems on the in the lab, and you need to show the work there. Otherwise, you're not going to get any credit. I can possibly give you partial credit if you just added wrong or something like that. Okay, here's a digital caliper. That looks like a pretty crappy one. Looks like plastic. You're going to want to get one that's all metal. But that just shows 837. Okay, the thing I'd like you to do before you do any measurement is to look at it and estimate about how big it is. because if you're completely off, then you'll pick it up. So kind of, I would write a number down, estimate, and then do your final reading. Okay, so we're going to zoom in on this. One thing you might notice is at the top there is kind of another scale, and that is the metric scale. Now we can go from English to metric really easy. It's 25.4 millimeters per inch. Okay, so we can easily change with that number back and forth between inches and millimeters. The deal is, though, that actually it's much easier to read, truthfully, in the metric system if you understand what's going on. We're reading along the bottom here, though. So I want you to do this problem. I want you to pause the video right here, and I want you to do this problem. Okay, welcome back. Hopefully, I'm going to go over it with you here now. Okay, so the first thing we see when we look at this is that we are at above 1 inch. Okay, so I'm going to have to write down 1 inch on here. Okay, then I'm going to see how many hundred thousandths. 100, 200. So I'm going to write down 200 thousandths. And then I'm going to say, okay, how many 25s? It's still only 125. So I'm going to write that down. And now we have somewhat more, and we're going to go over here until we find where it lines up. And it lines up at 17. It says, I don't know if that's, he was doing this on PowerPoint, so it's amazing that it works at all. And so he says 17 is where it lines up best. And you might have been now here's the funny thing. If one eye is dominant in your head, which it always is, you will actually pick up a different number sometimes than the person whose other eye is dominant. So you might be, that's where you get like 1 or 2 thousandths off when you read these things. Okay, so 0.1242. So 1 inch, 242 thousandths is that dimension. Okay, now we're going to read in millimeters. Now here's the problem. There are 2 types of verniers that deal with millimeters. Unfortunately, the one on the screen is not the one that we have, and I'll show you the scale on the other one in a second. They're either divided up into 0.05 millimeters, or they're going to be 0.02 millimeters. Now remember that 0.025 is 1,000th of an inch. So the 0.02 millimeters, that's going to be slightly more accurate, I guess, than you'll get a slightly finer reading than you will with the English system. If you have this particular one, its closest number is 0.05 millimeters. I don't know why it doesn't say it, but on this one, but usually right here or right over here, you see it says 1,000th of an inch is the smallest measurement, and that's here on the vernier. It should say 0.05 millimeters over here. Okay, but if you look carefully, these are tenths of a millimeter, because there's 10 of them, and that each one's divided into 1 division. Okay, if it's the other one, you're going to have 10 divisions, 10 major divisions, but in between each, you'll have 5 divisions. Okay, instead of just 1 division, and or 2 divisions between each one there. Okay. So how do we read this? Let's zoom in on it. Okay, so now here's something that bothers me. We see 1, 2, 3, 4, 5, 6 on the screen there. Okay, you see that? What are those? Well, it's not 3 millimeters, okay, because it's hard to see, on the screen here, but the distance between here and here is a centimeter, okay? So there's 10 between here, so shouldn't that be 20, 30, 40? Yes, it should. Why they don't do it, it's super annoying. But just remember that these are millimeters always, and that's 20 millimeters, 30 millimeters, and 40 millimeters, etc. Okay? So if I would read to the 0 on this, I'm going to see, okay, it's 30 something. Okay, so 30 millimeters. In fact, it would be much easier just to say, well, it's 31 millimeters, and then you add 31 millimeter, okay? And then you're going to say, well, where does this scale line up? Let's see if there's a zoom in here. They say it lines up here, which is right on 0.5 millimeters. Now, if it was one to the right, it would be 0.55. If it was one to the left, it'd be 0.45, okay? Unfortunately, this is not what you normally get because to the nearest half a millimeter, or 0.05 millimeters, I'm sorry, is 2/1000ths of an inch. So it's pretty coarse measurement compared to the English measurement, okay? So 31.5 millimeters, okay? So now, I'm going to show you the other one here now. You're going to look at this upper scale here. Hopefully you can read that. You see 10 divisions there along the top, okay? And if you read carefully here, it says 0.02 millimeters. And this one's kind of fancy because it has this other little thing here, and I'll show you what that is in a second here. Let's say I wanted to very accurately come onto something that was, I don't know, some diameter. I'm going to look around here if I want to measure the back of this thing here. Okay, so what I can do is I can clamp it on there, and what I can do is I can turn this one here, this screw here, and that'll lock it. But the other thing I can do is I can very accurately, if I want to actually make a dimension here, the other thing you can do is you can use this for making a dimension and then transferring it or somehow putting it onto the surface and either making a slight scratch or just, you know, saying, well, this is what the diameter should be. Okay, so how do I do that? I'm going to clamp over here. And what it does is this becomes stationary. This little slide becomes stationary. And this one over here is still sliding. In fact, I can move it back a little bit, back and forth a little bit. And what I'm going to do is I'm going to just snug just a little bit of tension on this, and that keeps the jaw from kind of like tilting, okay? Then what I'm going to do is I'm going to turn this little thread under here, and I can move that jaw back and forth because it is pushing or pulling on the actual vernier section here, okay? And this whole thing moves together, this whole deal here. And I can't really move it much right now because this is clamped. So if it doesn't want to move, you unscrew both of those, and now I can move it, okay? So I don't know if you can see this, but let's just clamp it right there, and I'm going to get really close with it. Boy, it's better than I can see with my eyes. So I would say that is 35, 38, and then I have to find out over here where it lines up. So if it's 38 and let's say it lines up, I think it's one left of the 5 there. Okay, so it is 38.48 because each one of those divisions is 0.02. Okay, so that's how you use a vernier that has the 0.02 in metric. Okay, how do you check your answer? If you know how to do it in English, then you can put it to metric by the conversion and then compare the answers. They should be very close, within 1/1000th or 2 of an inch. Okay, so that's how you measure vernier. How do you measure using a dial caliper? Okay, now this one's kind of screwed up a little bit. Someone must have dropped it or something, because the zero lines up over here. There is a way of going in here and changing that. But this one's different in that what we're doing is we're reading the 100,000ths place just here at the inside edge of this. Now you can see that's, I don't know, right now it's 400, not quite to 500. And so I just read up on the scale here, it's 480 thousandths of an inch. If it was like here, that's 495. Okay, right there, 491.5. So 0.4915 is how you do that. really though, I mean, when you clamp on something, you're not gonna. I mean, I'm just moving this just slightly. The other thing is, when you use your thumb, you put your thumb against this little wheel, and it allows you to kind of reel it back and forth really nice and evenly. Okay, if that's missing, it's really hard to use one of these things. Okay, so remember, I can do the inside of diameter, inside width. I can do outside diameter, and then I can do depth on this one as well. Okay, so that's how you measure that, and you'll have some exercises and a measurement lab to get used to using this. I would say the dial caliper or digital caliper is the most useful tool you can have for doing accurate measurement. I would probably get the 8-inch one just because it's a little bit more useful. There's some certain things that you want to measure that are just over 6 inches, and it's a little bit more useful that way. Okay. Have fun at the lab.